and we're evaluating logarithms. And I know you studied these last year. There's a lot to remember. One of the things I want you to remember, so maybe make a note of it, or maybe you already remember it, is when you have a logarithm, and there is a coefficient, like a 4, right there, a number right in front of that logarithm, that number is actually an exponent. So this problem is really the log base 2 of 2 to the 4th. Okay, so one of the things we need to remember is, if you ever have a coefficient in front of the log, that coefficient is actually an exponent. Okay? Another thing to remember is, whenever you have a situation where the base of the logarithm, log base 2, and the thing you're taking the log of, whenever those two numbers match, the answer is the other number. So formally, let me write that down as a property. The log base b of b to the n. Whenever you have that situation, the answer will always be n. So if you had the log base 8 of 8 to the 4th, the answer would be 4. If you had the log base 7 of 7 to the 6th, the answer would be 6. That's a property of logarithms. Okay, so I know the answer to this problem is 4. Now, this is an alternate variation of the same thing, the same property. Whenever you have this situation, again, the base and the base are the same number, then your answer is just going to be that. Now remember, what's ln? We talked about this last time. ln is log base e. No, e. ln is e. So e to the log base e of 6. See how these two numbers match? So the answer is just 6. So if you had 5 to the log base 5 of 6, that would be 6. These properties can be huge time savers, and they simplify stuff for us. Okay. Well, this is something you're just gonna have to figure this out. I don't know, log base 8 of 1, what is that? Well, I don't know, I'm gonna call it x, I don't know what it is. And now I'm gonna loop-de-loo it. We talked about that last time, right? Loop-de-looing. So 8 to what power is gonna equal 1? 8 to what power equals 1? 0. 0. What's 8 to the 0th? 1, right? That's gotta be a 0. The only way to get a 1 is to raise it to the 0th power. Now I heard somebody say, so the answer is 0, okay? I heard somebody say 1/8. Remember, this is not a multiplication, this is a power thing. So if you, that would be 8 to the 1/8. I don't know what that is, but it's not 1. It's some decimal thing, right? So this is a power. The only power we can raise it to and get 1 is 0. And what would happen if that were a 7? Would that change anything? No, because now it's 7 to the 0, but isn't that still 1? And whatever that is, if you're going to end up, if you're going to get a 1 out of it, you're going to have to raise it to the 0th power. All right, let's look at this one. Oh, I heard an answer. 1/2. How did you do that, Dana?
You set up log 7, where you just, I just know it because you put 7 in a root, that's 1/2.
Exactly. The square root of 7, the square root of 7 is 7 to the 1/2, isn't it? Isn't a radical a square root? I hope you remember that. You had to do that on your quiz today. A radical is a square root and vice versa. 1/2 power is a square root. 1/3 power is a cube root. So we have a property that says log base 7 of 7 to the 1/2 is just going to be 1/2. Same thing.
10.
Be careful. The base is 10. So you can either loop-de-loo it and say 10 to the x equals 100. So the answer is 2. Or you can think of 100 as 10 squared. And the log base 10 of 10 squared is going to be 2. Either way, doesn't matter. How about this one? Any thoughts on that one? -2. Very, very good. For those of you that are like, what? Okay, 2 ways to do it. We can loop-de-loo it. So 3 to the x equals 1/9. Isn't that 3 squared? But it's in the bottom, so wouldn't that have to be -2? Or you can go back to the original problem and say 1/9 is 3 to the -2, 1/3 squared. So that would be -2. Guys, we have to be able to figure this out, and I can't tell by the looks on your faces. I don't know what's going on. How about this one?
1/3.
1/3. Because what's the cube root? The cube root is a 1/3 exponent. So this is the log base 6 of 6 to the 1/3, which is just 1/3. How about
Wait,
this next?
on that one, can you, wait, no, never mind. I was just wondering if you could cross off and then you put it to the 1/3 and you cross off the 6.
Yeah. What is it? Somebody said something. What'd you say?
It's a -3.
You're -3, you're right. It is -3. Because this is the log base e of 1/e cubed, and 1/e cubed is e to the -3rd. So that's just going to be -3. Any thoughts on that last one, Herbert Cameron? Well, you can always loop-de-loo it, guys, always. You don't need to do tricky things. So 4 to the x equals 1/16. Yep, -2. You can always do it that way. Set it equal to x and loop-de-loo it. You can always do that, if that's easier for you. Okay, all right, we got, well, there's more. Okay, so Pete. Anybody have a thought on what the answer to problem P is? Remember that LOG is base 10, so I'm gonna sneak a 10 in there.
Do you cross off?
Uh-huh, what's the answer?
7.
7, yep, absolutely, the answer's 7. Remember, whenever you see an LOG, you can put a base 10 on it. That's what it means, base 10.
No, this is
3.
10.
All right,
This is,
log of 1,000.
oh, that's
It's 3.
That's 3, good. Some of you are getting this, and that's awesome.
Yeah.
Remember, those of you that are behind, don't go. Remember, we've got a base 10 here. We're trying to figure out what that is. So we can loop-de-loo it and say 10 to what power is 1,000? And we know that power is 3. You could also, if you wanted, go back to the original problem, you just told me 1,000 is 10 cubed. So if I take the log base 10 of 10 cubed, I'm obviously going to get 3 as my answer. one has that exponent out in front, or that coefficient out in front, remember that's an exponent. So what problem R really says is the log base 3 of 9 squared. Okay, does everybody see that? That 2 out in front is actually an exponent.
Can you make it to where it's a base of 3? Like the
Oh
nine
yeah,
squared,
that's
make
gonna
it
be
a base
my
of
next
3,
step.
And then
Yeah,
you get the answer?
yeah.
Okay.
Yes, what do we get the answer? Sure. What's 9 squared?
81.
81, but we know 81 is 3 to the 4th. So the answer is 4.
We read it, x equals 4.
X equals 4 is the answer. Yep. Now, you could also, back at this point, when you were here, set it equal to x and say 3 to the x equals 81. And then obviously x is going to be 4. You can do it however it makes sense to you. Just get 4 as the answer. All right, next one is log base 2 of 8 squared, 8 cubed, sorry. 8 cubed.
What is it?
Okay, so now Jake is bringing up an interesting point. He says, oh Lord.
Oh wait, no,
what's
2.
8
Oh, but you can just do 2 bases.
Exactly. It might be easier, Jake, to change that 8 into a 2 cube and then cube it.
So 2.
So this is 2 cubed right here. What do I do with those exponents?
Multiply.
Nah, the answer's 9. Yep, the answer's 9.
That was true.
What do you think the answer to T is?
4.
4. Remember, what's ln?
That's
Log
E.
base E.
Cancel.
They cancel, and the answer is just 4. All right, now we have some more of the same thing, only these are written as equations. It's basically the same thing. So your job is to figure out what x is. Remember, that base is 10. You lose our friend. So we get 10 to the 3rd equals x. So yep, the answer is 1,000. See how easy that is? That's easy. LOG, put in the 10, and then you do it. How about the next one?
X equals 0.
X
No.
equals
10 to the negative first equals x. What does 10 to the negative first mean? 110. 110? Elijah's over here. He says 1 over 100 is the next one. What do you think about that? Charlie agrees.
I agree.
Everybody agrees.
Yep.
Nobody wants to disagree with Elijah? Because he's right, right?
Yeah,
He's
that's
right.
exactly why.
1 over 100. Ooh, what about D?
Log E.
So remember, the base is E. So just rewriting my problem, this is what it looks like. So, loop-de-loo, E to the 4th equals x. That's the answer. E is an irrational number like pi. It's 2.718 approximately. But you remember in geometry class when you had to find the area of something and you said 12 pi, and that was okay? Same thing here. You can leave pi in an answer, you can leave e in an answer. So e to the 4th is our answer. What's the answer to e?
6.
E to the 6th. E to the 6th.
This one is 0. Right?
Okay, now I want you to think for just a second.
It's 0.
It's 0.
It's 1.
Okay, we don't know, it's a 0 or 1 or something, right?
It's 10.
So,
It's 10.
let's, 10, I like that, I like that. So how did we get that? All right, stop a minute. This is an equation. You can divide by 3. It's an equation, you guys. It's a regular old equation. So we're gonna divide by 3, and now it says the log of x equals 1, and the base is 10. So 10 to the first is x, and x is 10.
When you do like 10 to the 30 equals x to the 30, just
Absolutely. So Elijah says, let's look at this, because he knows what he's talking about. And I want all of you to be open to doing it however it works for you. So Elijah says, Mrs. Ford, you told me that a number out in front is an exponent. Right? True. Absolutely true. Base is 10. 10 to the third equals x to the third. So what's x? 10. So it doesn't matter how you do it. You can think about it however you want. All right, some of you've already got the next one worked out. I would suggest, my own personal preference, especially since it's negative, is just divide by it. So I would have this equation. If I divide by -2, what's ln mean? Well, it doesn't mean e, it means log base e. So e to the -2 equals x. We don't like negative exponents, so how could I rewrite that? No,
1 over e, 1 over e, 1 over e.
1 over e squared. 1 over e squared. When do I put fractional exponents in? Only when I have radicals, right? Radicals are fractional exponents. Negatives are 1 over. What was that, h? No, that was g, not right. All right, how about log x equals 1/2? What's my base? 10 to the 1/2 equals x, and a 1/2 exponent is a square root. So this is the square root of 10.
But so if there's always a fraction, there will always be an answer in the square root.
Some kind of radical. Now it's a square root because the fraction was 1/2.
Oh, but
In the next one, the fraction's going to be 1/3, so it's gonna be a cube root. Anytime your exponent is a fraction, you're gonna have a radical. Okay, you're going to have a radical.
Yeah.
But whatever the fraction is will determine what radical it is. Okay,
Yeah.
what is it?
4 root e.
So log base e of x equals 1/4. So e to the 1/4 equals x. And what does that mean? The 4th root of e. A 1/4 exponent is going to be a 4th root. A 1/2 exponent is going to be a square root, and so on, right? Okay, 3-3 homework is due on Friday. Now we're gonna get started on 3-4. Do as much as we can. Maybe just do this front side. Let's get A through F done, and then I'll be quiet, okay? Tell me if you remember anything about combining, condensing logarithms.
If they're the same base.
Okay, there's step 1. They have to be the same base. Now we're in luck here because so far everything is base 10, so that's good. Patton?
Is it subtracting like division or something?
Yes. Exactly.
Oh.
When you have a logarithm minus a logarithm, when you put it together and write one logarithm, that's the job, write as a single logarithm. So if you log something, this one's gonna be log something. If the logarithms are being subtracted, when you put it together, it goes together as a division. So this would be x over y, and it's first over second, so x over y. This correlates to what you know about exponents. In a division problem, what do you do with the exponents? Subtract. In a division problem, you subtract the logarithms. The properties are the same. So when you're going to put it together, these are going to go together as a division. Now, this one's different. It's going to go together as a multiplication, but there's something else you have to take care of. This guy is an exponent. So what am I going to be multiplying in there? X squared times y. Beautiful, beautiful, beautiful. 1/3 log z plus 2/3 log w. I don't know what you're going to do here, but somehow you got to get it all put together. It's going to be log of one thing. There's only going to be one thing. So what's in there? Is it going to be multiplied or divided? Multiplied. Right. So what am I going to be multiplying? Z to the 1/3
W to the 2/3.
and W to the 2/3. And you can leave it just like that. You can leave it just like that. Could you rewrite it as the cube root of Z and the cube root of W squared? Absolutely you could. It wouldn't be wrong if you did it, but you don't have to. You can just leave it like this. Okay? Vincenzo, you okay?
Yeah, my bad.
Okay. All right. D. Try D on your own. See what you can come up with here. You're going to write this as one logarithm. So give log of something. I heard somebody say 1.
Yes. That's what.
Let's see. I don't know. So what happens to the 1/2?
4.
Well, it becomes an exponent.
Yeah.
So it's 16 to the 1/2, which means the square root of 16, which is 4. So that's a 4 over whatever this is, division. Okay? So that says the log of 8 to the 2/3. You just took a quiz. What does that mean? The cube root of 8 squared. The cube root of 8 is? The cube root of 8 is 2, and 2 squared is also 4. So when you said it's the log of 1, you are right. But if you're going to be an A student, you're going to say the log of 1 is 0. Because what's the log base 10 of 1?
0.
Gotta be 0.
0.
The log of 1 is 0.
Okay. Picking up and like that.
8 is the cube root of
Root squared.
See why we gotta know our exponent rules? Because they show up all over the place. All right, 2 more. Here we go.
54.
ln, or 3 ln 2 plus 1/2 ln 36.
Oh, it's 48.
Now,
Yeah.
the fact that it's an ln doesn't change anything. That's a logarithm. The rules are the same. So my answer is going to be ln something. So this is 2 cubed. So that's 8 times 36 to the 1/2, which is the square root of 36. 6? ln 48. One more and I'll be quiet, alright? What do you think about the last one?
X,
4
minus the 4.
log xy
X to the fourth.
minus 3
Yep,
log
X.
x. Okay, we're gonna write this as one logarithm, so what's gonna be inside the parentheses?
X to the power 1. Oh,
It's gonna be a division, right?
yeah. X to the 4.
X to the 4th, y to the 4th on the top,
Yeah, over X to the third.
over
To the
x to the 3rd. Did everybody keep up with that?
Yep. Yeah.
Okay, now we can simplify that, so we will. So that's the log of
X,
X,
Y.
Y to the 4.
x, y to the 4th. Boom, as you guys say. Alright. So 3, I forget, was that 3, 3 or 3, 4 we finished? 3, 3?